Hi economists, in this video I'd like to explain the difference between a tax per unit of output and a tax per unit of carbon emissions when it comes to governments addressing the negative externalities of pollution, the negative production externalities of pollution. So we know that whenever there is an externality, there's a welfare or a deadweight loss, meaning there is a reduction in the social benefits due to the misallocation of resources. So we're going to illustrate that in a moment. The problem of environmental pollution, such as the smoke emitted or the waste dumped by a producer, is created as a side effect of production activities, and we very commonly analyse this in the context of a negative production externality or an NPE. So with a negative production externality, there's an over-allocation of resources to the production of the good. So if we were only to consider marginal private costs, our supply curve would be here. But we want to actually consider the external costs of production, which would give us the marginal social cost curve here. And the external costs, the smoke emitted, the gas, the waste, etc., is represented here as the difference between the marginal private cost curve and the marginal social cost curve. So you can copy these diagrams down if you want and write them more clearly. So external cost is here. So we also know as a general rule that the welfare loss or the deadweight loss points to the optimum position. So in this case, the market position is here at quantity M and PM. And the if we're to consider the external costs, just fill that in yourselves, the optimum position would actually be here at Q opt and P opt. Okay, so therefore, if the deadweight loss points to the optimum position here, then we by logic put our deadweight loss triangle here. So that's where you would put the deadweight loss. Okay, moving on. Governments have several ways of correcting this negative production externality of pollution, and what we're going to look at in this short video is the use of a tax. And there's two types of tax available to the government. The government could impose a tax on the producers per unit of output produced, so per unit of quantity produced, or the government could impose a tax per unit of pollutants emitted by the company or the firm. So if we look at the tax per unit of output produced, which is sometimes also called a Pigovian tax, this provides the incentive for producers to move from the market position to the optimum position, and really just reduces the quantity of output produced without doing anything about reducing the amount of pollution created in production or encouraging firms to switch to less polluting resources. So the optimum tax in a tax per unit situation would be to tax to the extent of the external cost. So to move us to the marginal social cost curve by shifting us along here. Okay, so the second type of tax is the tax per unit. So this is the tax per unit of production. Or output, per unit of output. And what we are going to look at also is the tax per unit of pollutant. Tax per unit of pollutants. Okay, so this is sometimes also in the form of a carbon tax. That's an example of a tax per unit of pollutants. All right, so once again, we have our supply curve or our marginal private cost curve here, and our marginal social cost curve here, which is, and the difference is the external costs of production, which is the pollution, and the other negative production externalities. So with the tax per unit of pollutant, governments are trying to create incentives for firms to buy fewer polluting resources such as the fossil fuels, and to switch to less polluting technologies, such as alternative energy sources. So fossil fuels do not all emit the same amounts of carbon when burned, so therefore the carbon tax is calculated on the basis of how much carbon the fuel emits. So the more carbon emitted, the higher the tax that will be paid. So, okay, so let's just go through how this works out on our diagram. So after the tax is initially imposed by government, firms do shift to here initially. So that moves the curve initially from say this curve to this curve. But with this incentive, and that's a key economic term, is incentive, to switch to less polluting production techniques, then producers would then pay less tax. So initially we move from this position, QM, PM, to this position, which is the optimum. Let's just put that in a different colour, Q opt and P opt up there. But because we are now, as producers, going to switch to less polluting production techniques, then we're actually going to shift to a new curve, which would be in the middle. So let's make another colour here, which will be the MS, we can call that MSC2, so marginal social cost 2, because we know that when our costs of production reduce, our supply curve shifts to the right. That's a basic principle we've learned earlier. So with moving to pollutants that emit lower levels of carbon, we are going to pay lower levels of tax, which is why we make that shift back down here. So the end point is actually higher levels of production, but using more, cleaner energies. So you'd end up at Q opt 2 after the tax works its way through. The producers have that incentive to switch to less polluting production techniques, and we end up with the increase in supply as we looked at there, and the quantity increase back to here, this level. So the overall impact, as I said, is the cost of production are now lower, so firms can increase their level of production and shift to the MSC2. And so what do we want to say? So then essentially let's look at the deadweight loss before we finish up. So originally, what we want to really point out here is that the deadweight loss would originally have been similar to this one, in the sense that it would be pointing to the optimum position on the MS marginal social cost curve. So it would have originally been this big, but after we move to the MSC2, it actually reduces down to this size. So it's now the external cost, the deadweight loss, is only that much now. Okay, so hopefully that makes sense. The size of the external the negative externality is actually decreased, and the deadweight loss is, as I said, smaller, but also we can now produce a bit more as well without creating too much environmental degradation. So this compares obviously to the other curve, the Pigovian tax, the tax per output, where all we're achieving is a reduction in the quantity produced to incorporate that tax. But this actually creates, this different model creates more of an incentive and changes the actual behaviour of the producers in the process to switch to more environmentally friendly technology. Okay, thank you. Hopefully that made sense.